This is our somewhat annual overclocking gathering for the overclockers we work with all around the world. And specifically, this time we are doing overclocking on the soon-to-be launched Granite Rapids platform, the upcoming high-end desktop platform for Intel.
Granite Rapids is our Xeon 600 processors for Workstation. The Xeon 600 processors for Workstation are really incredible for people who are looking for high performance. So a lot of the engineering and scientific, people doing simulations, love these machines where they need a large number of cores. So it scales all the way up to 86 cores. But the thing I'm excited about is its memory subsystem. 8 channels. And having 8 channels of DDR5, so we use RDIMMs on the platform, is an amazing opportunity for overclocking. The bandwidth, the sheer bandwidth is amazing. And that's where you'll see a lot of the overclockers capitalize on that bandwidth.
Memory overclocking is very, very strong on GNR. And our partners were able to take advantage of that, to break a bunch of world records that are very sensitive to memory bandwidth and performance. And yeah, you see a bunch of those records being broken just because of how strong memory overclocking is on GNR.
I think overclocking has always been a very interesting question, because in olden days, most of the time when we're talking about overclocking, most of the time we're thinking about overclocking are only for gamers. But right now we're seeing a different trend. The fact that even workstation motherboards running a professional workstation CPU can do overclocking has surely been very fascinating for those workers. Overclocking is always a matter of great balance between stability and performance. So the key is to find out that great balance between stability and performance.
So I've been called in basically as an overclocker by Asus to participate in this pre-launch kind of secret overclocking event where we push Intel's latest platform to the limit.
This event is kind of an annual thing, so every time Intel comes out with a new platform, Asus invites us, enthusiasts and overclockers, to come and try out the platform ahead of launch. And a lot of the people here, they're focused on trying to break world records using liquid nitrogen. And I'm pretty much the only one here who just uses water cooling. So approaching it from kind of a more normal perspective. Normal in the sense that I use ambient cooling. Not so normal because I'm still trying to squeeze as much performance as possible out of the platform.
It's a bit of a dream because that's my first time being invited to an event like this. I already came here a few times ago, but doing that for a special event like this was the first for me. So yeah, I'm living a dream right now, I would say.
It's always a great time, you know, everyone comes together at one location. We have some people that's been doing this for the past 20 years and some people that started last year, so it's a nice mix of talent and never gets boring.
It's a true honor to be with these guys because Asus gathered a team of like the best of the best, world class. I mean, overclocking in general is a very individual thing where you are at home most of the time, you know, doing your own overclocking endeavors. And meeting up with these guys is a true delight, and you can share your experience and talk face to face with, which is amazing.
When we do these overclocking events, we're usually trying to compete with other people. So we're going for these global first places or world records. And we have a website called HWBot that keeps track of all these different scores that people do and gives you like a rank and even points if you're into collecting those.
The world record is basically across all categories, so you're number one, no one else has beaten you in the overall score, whereas a global first place is per category.
Like in the Olympics, you have different, you know, sports and categories, and a, let's say, 28 core would compete with a 28 core. And if that new 28 core gets the best score in its category, it would be a global first place. Whereas a world record is the fastest system overall. So, for instance, here, the one with the highest scores is likely to get a world record, but doesn't have to. So the 86 core can get the world record. If there would be a 40 core with insane IPC, it could still get the world record and at global first place in its 40 core category. So if that makes sense.
I started overclocking a very long time ago. I think my very first real overclock was when I built my PC. I think I was 14 years old, something like that. I've always been kind of driven like from a performance perspective. So I got some benchmark numbers and then I wanted to get a higher number, and slowly you try to figure out how to get a higher number. So you look at the hardware, you also look at the software, and just step by step you learn more about how to optimize the performance. I used to do a lot of the competitive extreme overclocking as well, even qualified for some of the world championships in the past. And then it was more the competitive spirit of, okay, I want to win the competition. But nowadays, I'm not really that active on a competitive level anymore. I just focus on trying to squeeze the most performance out of a system. And then I make these guides for my YouTube channel where I teach people how to do it. I like to set up my system in kind of an organized fashion. I'll use the open bench table as a platform to mount everything on. And then on top of that, I'll mount, we call it like a bench lab, which is a PCB that sits between the power supply and the motherboard. And it allows me to capture all of the telemetry of the system. So I can monitor power, current, voltage, temperature, fan speed, and so on. And then on top of that, I'll have the motherboard, and I'll make sure that the cooler is fit tightly. I'll make sure that the memory is slotted in perfectly, and then I basically get going. It's a little bit less work than setting up your system for liquid nitrogen, right? You don't need to do any kind of installation. You just need to make sure that everything fits tightly and well strapped together.
Back in early 2000s, my dad was doing some overclocking on his laptop, like an old Asus one. So I learned from that because what I saw is that in gaming we could gain some more performance, right? 5 years ago, I started learning about extreme overclocking. When I start meeting on Discord some friends that are here today, and they teach me how to overclock with liquid nitrogen, and it became a hobby. Now I'm mostly doing overclocking and not much so gaming. We use heater to keep the board at a certain temperature. Some people use some kind of different insulation on the surface. Some people will use Vaseline. Some will use towels around the CPU pot container. I don't use personally on my side Vaseline. I just have 2 heaters on below the board, towels around the pot, and that's it.
I first started overclocking when I was a teenager, trying to build my own PC and play the latest games, and being on a budget, you turn to overclocking to try to get a little bit more performance out of your system. That kind of escalated, and you started comparing, is my PC faster than my friends or even some random people online? And then you figure out like, oh, if I make my cooling better, I can get more performance out of it. And living in Sweden, we get very cold temperatures during winter, so you open your window, you get higher overclocks, right? And how do you get colder than that? Then you start experimenting with things like dry ice and liquid nitrogen, and that's been the journey from there. So different overclockers will have different personal preferences, how they like to set up their system. It goes into things like, what do you use as your benching platform? Do you use some kind of bench table? Do you just use like a motherboard box or pre-cut foam? Which thermal paste do you use? And a lot of times it's just, I like this one, so I'm going to use it. I've had good results with it in the past. I tend to be pretty flexible, so like I'll listen to other overclockers, their lessons, and what did they learn, and I try to take that into account, and then I try it myself, and if it works well for me, and you don't waste a lot of time setting up the system, because like time is also of the essence. These events we usually do for a week, so that's the amount of time you have, right? So if you waste 2 days setting up your system, then you only have 3 days to try to get a score, right? So you need to balance it a little bit.
I started out around 20 years ago, I would say, when I didn't have a fast PC. So I did want to play, I think it was Battlefield 2 or something like that. I just wanted to push 60 FPS somehow. So I bought this PC and started overclocking right away. I got notice of these overclocking and benchmarking sites like 3D Mark, where you have a leaderboard and you can compare your system. That eventually became more of the game that I'm playing now. It's just ranking up in these, leaderboards, be it 3D Mark or HWBot, to just, get higher scores. Prepping for me is an absolute cornerstone when I get my system ready. You guys might have seen me this year's Computex, where I won the G-Skill overclocking competition, and their preparation is key because especially in Taiwan, the humidity is much higher than in Europe. So therefore you gotta insulate all your hardware from the motherboard to your memory sticks. Everything gotta be insulated because electronics and water don't mix well. And other than that, preparation-wise, you spend a lot of time at home basically for these events, getting the ideal settings for what you want to run. So if you then get different hardware on some of these events, then basically you can narrow down the variables to that specific part that has been changed.
It's been 25 years or so, and it was just for gaming. I wanted to play games. I was a student, I don't have a lot of money to spend, I wanted to save money, so I really needed to squeeze every bit of performance I could for free from the hardware. Over time, I grew obsessed with it, trying to get every last frame rate out, and then you have to work on the hardware. You need better cooling, you need to find ways to feed the processor with more voltage and all that. So gradually my interest shifted from gaming to overclocking itself. I do this a lot, so whatever saves me time, I would do it. And for example, a lot of them don't like Vaseline on their boards because it's greasy and sticky, whereas I just cover the whole board with Vaseline. It always works well, and it's fast. Another thing though, on this platform, the mounting for the socket is kind of different. The pressure exerted on the processor is also very important for overclocking. There's always this way of mounting, like there's a certain type of springs, and with I even have the nut upside down just because it works well for me. And for us, if it works well, we don't want to change anything, I would have this fixed pattern of mounting the CPU and all that. I cannot explain why, I can just tell you it's worked well. So it's kind of a superstition for me.
So when I'm picking which parts I'm gonna use for overclocking, I usually start out testing the system on air cooling, kind of figure out where the limit is. Does everything work well together? Is it easy to work with? When you're doing extreme overclocking and you add these sub-ambient temperatures and you have to deal with condensation, mechanical stresses in the system with temperature changes, you need a solid baseline so that you don't get tripped up by something minor, so you can focus on getting the best score possible.
In general, when going for overclocking records, all the silicon is a little different, right? I mean, obviously they all run within spec, but if you want to really push to world records, you gotta bin through a bunch of these. So we say binning is winning, so you gotta go through 20, 30, 40 chips, whatever, and select the best one for the purpose. And then, you gotta bin for the likelihood of going to as cold as possible as well.
Most of it is supplied by Asus, so I use what they give me, and hopefully it's the best. But again, at this kind of events, the majority of the people here are here to break records, so they'll get the top of the line stuff, and I focus more on what you could get in a real world scenario. So then I don't really need the top bin. I can use one bin lower than the top bin.
We chose to select a few benchmarks, like, okay, this CPU could be good on Y Cruncher, on some other benchmark. Let's try them first, see how it goes, and if it goes to the plant, let's try some overbenchmark. But it's mostly about guessing before having the CPU in our hand where they can be good. We know that this CPU can be very, very good with memory bandwidth, so we chose a few benchmarks that were very memory sensitive.
You have to over-engineer a lot of parts on the board to be able to, meet the expectations or be sufficient enough for them to push the hardware to the limit. The thing is that when you're testing for extreme overclocking, you discover things that you would not have otherwise. And a lot of times it helps you make the product better. Just as a testament as to how determined we are when it comes to overclocking, I would like to use this board as an example. This is my development board for a few months while working on this platform. We kind of want to leave no stones unturned so that we can give the best overclocking experience possible.
So as an overclocker, I'm pretty excited about overclocking 86 cores simultaneously. See, there's built-in margin when we have a base frequency for 86 cores. It tends to be much lower than if you had, say, a 16-core processor. The overclocking headroom is substantially higher. In fact, small overclockings can result in, for example, 40,000 megahertz of combined P-core overclocking headroom. So those are impressive headrooms that you just can't see in a lower end, lower core count processor. And it's a new world with Workstation that you can see those kind of performance deltas due to overclocking. And all you got to do is cool it and provide the power, and you can realize that capability.
The core count allows us to basically scale the headroom that we have. And in terms of the new instructions, we have TMUL and a VX512. We have offsets for that. That allows us to reduce the frequency slightly when you're running those heavy instructions. And that allows you to basically get a better performance.
For Workstation platforms, I would say the biggest difference compared to mainstream is the power consumption. That'll be the first thing that you need to address. So you need to make sure you have a good enough power supply, you have a motherboard with a very decent voltage regulation, and then also you need to take care on the thermal side. For example, on mainstream desktop, most of the time I'll use a single 360 radiator, maybe an all-in-one cooler or custom loop water cooling, whereas for Workstation, I'll switch to two. So I have a cooler here, basically a radiator tower with two 360 millimeter radiators. And that's because on mainstream desktop, maybe we'll get up to 350 watts, whereas on a Workstation, very easily we get up to 1,000 watts.
It's more challenging in the sense that it's a big processor. There are many costs on it. To maximize the performance, you could spend significantly more time tuning each core to maximize the performance. That's one thing.
On these new Xeon processors, one thing we have to deal with is the sockets are now so huge with all the connectivity. It's getting more and more complicated for us to get the right mounting pressure with our liquid nitrogen containers and things like that. Just yesterday, for example, we started flipping over our thumb screws so they're upside down, and then we figured, okay, now it actually works if we do this, and now we just kept doing that, like you kind of, you try to make sense of everything, even if it doesn't always make sense.
The memory can go really high on for this octa channel on ambient, but once you go cold, you can introduce some memory controller difficulties that you can try to overcome with different set of voltages and all that. For sure, it is a balancing act between the correct temperature, maxing out memory, and also the core clocks.
Those would be kind of the top three. So first, taking care of the power, then less focus on single core versus all core, and then the memory tuning is slightly different as well. Nowadays, it's pretty easy to get into overclocking. You just need to make sure that the parts that you put into your PC are enabled for overclocking. So make sure you have case Q, or in the case of Workstation, you need an XQ processor.
Try to get into the community via forums, Discord channels. There are a lot related to overclocking in them. and get into the community, know people from there, exchange ideas, participate in discussions.
Get with people, try to find a community online. Sharing the experience with people is probably the easiest way to do it. And also, it's more fun.
On these latest hardware, on these motherboards, they usually come with presets, pre-baked profiles that are validated by overclockers like us, and therefore proven to work. I mean, obviously there's going to be a bit of variance in your own setup, but then you can, see how it behaves and go step by step that way.
And then slowly over time, like many of these other overclockers, you move up the ranks, you get in touch with vendors, you get vendor support. That will really help you in this career.
And you have to check my YouTube channel as well.
We love working with our ecosystem partners on all these overclocking opportunities. In fact, it's an amazing relationship because we'll challenge them with a new feature, something new that they can take advantage of, and they'll shoot back other ideas, other opportunities. So we work very closely with those partners. In this time out, Asus in particular has been an excellent partner, just chasing down these overclocking world records. Particularly, Granite Rapids created some opportunities to focus on memory-based records. And so there's a whole slew of memory-based overclocking records being set.
Getting a record or global first place is absolutely amazing, feels incredible. For instance, I was fortunate enough the week before I came to Taipei to set the record for memory frequency. So that's truly amazing, seeing the progression of the technology.
I earlier this year broke a world record on the memory frequency. Once you are almost done, there is also a few extra steps that can go wrong. Once you submit the file, you see, okay, valid, I got the record. Like all the pressure goes down and you feel so good.
It feels pretty good when you get the world record. In a previous recording, you guys saw us get the over 9 gigahertz with liquid helium, and you'll probably see how ecstatic we were reaching that.
I've been doing extreme overclocking for now 20 years, and it's still always such a cool moment whenever you manage to get a world record. Somehow it never, it's a feeling that never gets old, no matter how long you keep doing this for.
One thing I really appreciate about Asus is they are relentless in the pursuit of performance, and they will not give up until they get those world records. I think Granite Rapids made some of them a little bit easier, but make no mistake, Asus pushes hard. And they have a team of skilled overclockers, a diverse team really distributed across the world. They bring them all together and they work together as a team to set these records, and it's just really inspiring to see that and see them push our product to its max.